Hello, my dear students. Welcome to the class of 11th English Medium. The subject is Statistics, the chapter 2, Presentation of Data, brought to you by Vitan Sir. In the last tutorial, we started with what is presentation of data, in how many ways it is presented, and the classification of quantitative and the qualitative data. In today's tutorial, we will study one of the types of the classification of quantitative data. The two types are discrete frequency distribution and the continuous frequency distributions. Both of them are the types of the classification of quantitative data. Among them, what we are going to discuss today is the classification of discrete frequency. It is the classification of the discrete variable. Now, we know that the quantitative data has two types of variable, that is discrete variable and the continuous variable. So the classification of discrete variable is the discrete frequency distribution, and similarly classification of continuous variable will be the continuous frequency distribution. The numerical value which shows repetition of the observations is denoted by f. Now f is frequency. Okay, what we say frequency. Now this is something which you have already studied in the 10th mathematics. Okay, that number of observations are given and the number of times they are repeated is denoted by f, that is the frequency. So that is how we classify the data using a frequency. If we want to define a table showing various possible discrete variables along with the respective frequencies is called discrete frequency distribution. So this is the definition of the discrete frequency distribution. Now if we want to understand it better, we just have to take some practical examples so that we can easily get the idea. Number of road accidents per day of a certain place is given as follows. We have to classify it. Means that the number of road accidents per day of certain place is given, and now we have to classify it. This is your data. As you can see, almost 30 days data is given. Each day how many accident occurred on a certain place is given. For example, on the first day 0 accidents, then on the second day 1 accident, then on the third day 3 accidents, etc. data is given, and this is called the raw ungrouped data, and we need to classify them according to the discrete frequency distribution. Now, so for that I have prepared a table here. I will give the title, number of road accidents, okay, then the telemarks, okay, and then the frequency. Now telemarks is something which you are very familiar with. Telemarks are singular vertical bars which we put for each random data here. We will get back to it shortly. Now how many variables are there that we have to decide first? As you can see, 0 accident, 1 accident, 3, 2, 0. Okay, 0 is repeated. So one of the road accident is 0. Then immediately next accident is 1. Then 2 is there, yes. Then 3 is also there. Then 4 is there, yes, 4 is there. Then is 5, yes, 5 is also there. Then are there 6 accidents? No. So the maximum data is 5 and the minimum data is 0. So the number of road accidents we will write down as 0, 1, 2, 3, 4, 5, and it will be very good if you write them in the ascending or descending order. Yes, whenever we are classifying our data, always try to arrange them either in ascending order or the descending order. And for the sake of simplicity, we 99% of the times arrange them into ascending order, and then the last will be total. Now we are going to start with the telemarks. Okay, what we are going to do, we are going to start with one by one taking each and every observation and putting a mark in front of that observation. Okay, the first value given in the data is 0. So this will be the one telemark in front of 0. Next is 1. So I will put 1 mark in front of 1. Next is 3. So it will be 3. Then comes 2. Then again 0. Then 3. Then 4. Then 5. 0. 1. 0. 2. 0. So you must remember that when there are 5 tally marks, we have to put one crossbar to make it a group of 5. Okay, then 1, then 3, then again 3, then 0, then 2, 1, 2, 4. Okay, first time, second time 4, 5, 0, 1. Okay, that was a crossbar. Then 0, then 2 times 2, so crossbar and again a single bar, then 0, then 1, and then 2. Okay, so these are all the tally marks which we have done right now. You have to follow this method if you don't want to make a mistake. Okay, so what we are going to do next is we are going to make a total of the tally marks. The group of 5 will be directly taken as 5 and the other 4 bars, that means there are 9 times 0. So 0 accidents occurred 9 times. You can verify it from the data if you want. Then 6 times 1 accident, 7 times 2 accidents, 4 times 3 accident, 2 times 5 accidents, and 2 times 4 accidents. So your total is 30. Okay, so just like the previous sum which we did, let us take one more example to still understand it. In this tutorial, we are just going to take examples of this discrete type of question only. Defects in the TV sets are given as follows, and we have to classify it. Now, the defects in the TV sets are given this time around, and we have to classify them. As you can see in the question, we have almost 50 observations, and it is 0, yes, 1, 2, 3, 4, and 5. Okay, so it is from 0, 1, 2, 3, 4, 5. So minimum data is 0, maximum data is 5. So we will have to make a similar table like the last sum, but the title here will be number of defects, then the tally marks, frequency, and then 0, 1, 2, 3, 4, and 5, and then it will come as total. Okay, tally marks we have to give one by one. The first is 0, then comes 3, then 2, 1, 0, 5, 2, 3, 0, 2, 3, 0, again 0, 1, again 0, 2, 3, 4, first time 4, 1, 0, many zeros are there, 4, 5, 2, 1, 0, 3, 2, 1, 1, 0, 2, 4, 2, 1, 0, 0, 0, 3 times 0. Okay, 1, then again 0, then again 1, 3, again 1, 3 times 0. So 1, 2, and 3 times 0. Then again 0, and 1, 1, 0, 2. Okay, so that there were so many zeros, but they are the number of defects, so it is good that 0 defects are there. So what we are going to do next is make a total. There are 3 groups of 5s and 3, so that means 18 frequency for 0, then 2 groups of 5s and 2, so 5 2s are 10 and 2 12, then comes 5 and 4 9, then 5 and 1 6, then 3, and then 2, and altogether the total is 50. So total number of TV sets were 50 and defect wise we have classified them. So 18 frequency, 18 TV sets have 0 defects, 12 TV sets have 1 defect and so on. So this is how we classify the data. We will take one more sum. The data regarding number of children of 50 families residing in a certain area are given below. Prepare appropriate frequency distribution. Okay, now as you can see, these are the data of number of children. 1 is there, 2 is there, okay, 0 is there, so minimum is 0, then 1, then 2, and then 3, and then nothing else. Okay, so the data here is 1, 2, 0, 1, 2, and 3. So we will put that data accordingly. The title here will be number of children, telemarks, and the frequency. Okay, so I will put down the number of children 0, 1, 2, 3, and then comes the total. Now the main task here is putting telemarks. We will start with the data given. 1 is the first one, then comes again 1, then 2, then 1, 2, 3, 4 times 1, 1, 1, 1, and 1. Then comes 2, then again 1, then 0. Okay, then again 0, then 2 times 2, then 0, then 2 times 3, then 2, then 1, 2, 1. Okay, you have to go one by one like this, else you might make a mistake. Then comes 2, 1, 3, 1, 1, then 3 times 2, then 1, 2, then 3, 0, 3, 0, then 2, 1, then 4 times 2, 1, 2, 3, 4, then 0, then 1, then again 4 times 2, 1, 2, 3, 4, then 2 times 3, 3, 3, and then 2, 1. Okay, so with this we have completed our tally marks. The frequency for 0 will be 6, then frequency for 1 will be 16, the frequency for 2 will be 21, frequency for 3 will be 7, and when we make a total of all of these things, it becomes 50. Okay, so with this we end the number of sums which we are going to do for this tutorial. What I want you guys to remember for this particular type of discrete frequency distribution is that the difference between the highest and the lowest observation is called range of the data. Okay, so the highest observation, for example, if it was the children, it was 3, and the lowest observation was 0. So the difference was 3 minus 0, 3. So 3 was the range of the data. Before that we did maximum 5 and minimum 0. So the range of the data was 5 minus 0, 5. So that is called the range of the data. And if range of the data is very big, for example, the marks of students out of 100, so maximum will be 100, minimum will be 0. So 100 is the range of the data, and if it is very big, we can take 0, 1, 2, 3, 4, 5, 6, 7 up to 100 in a single table. So we can't use the discrete frequency distribution when the range of the data is very big, and in that case, in its place, we should use the continuous frequency distribution. In the next tutorial, I will discuss about this continuous frequency distribution. Till then, stay tuned, stay home, and stay safe.